So we've only got one slide of takeaways. So I guess we charged the group with the challenge to talk about how we get to the point of having something of an agreed framework for pharmaceutical use cases. And I think one of the main sort of themes of the conversation was a little circular at times, which this topic often is, was the idea of sort of separating out use cases and starting with developing a framework for validation of NAMs around the easier use case, which is decision making in drug discovery. And actually, in actual fact, the theory was that many of the foundational components of a validation system in that space has common features with what you might want in a regulatory case as well. So it would build on that for the future. So I think we talked about the fact that a validation framework is required. We talked a little bit about the fact that nobody has the expectation that in vitro or in silico NAMs in isolation will ever really replace in vivo models. We saw them as a sort of complementary data set to improve confidence. We also talked about the fact that there were actually a number of use cases already out there where you are actually making really serious both drug discovery decisions and regulatory human risk assessment decisions on the basis of these in vitro systems. So this is already happening. And I think what we need to do as an industry is focus in on what that validation framework could look like. So just to give you a sense of the sorts of things we talked about in terms of validation framework, we talked about sort of the idea of biological credibility. So you could readily define that in framework terms, right cells, right microenvironment, right biomarkers, particularly in a pharmaceutical industry use case, you have to talk about experimental scale. So many of these assays need to run in microtiter plates and run with throughput. Predictive ability, of course, is key. And this was all about using the right compounds, making sure you use the right dose, make sure you're measuring the right things. And we felt that this predictive ability can only really come from industry-based sharing of data. So it sort of comes back to the same theme again. Positive compounds, negative compounds, compounds in the gray zone. You need all of them to really thoroughly validate a NAM. And I think the sort of industry momentum around the need for data sharing is something that CPATH can definitely, I think, contribute to. There are two other areas that I thought I would just bring up that we touched on in the session. One was as you run these assays at scale, you are building data sets that support future AI models. So we should also, as part of this validation framework, guide and advise organizations around generating data with AI in mind, which is essentially what we've just been talking about. You know, I've been wrangling with Charles River data for a few years. We have a ton of, as you can imagine, toxicology data, but it's legacy data. It's hard to work with. We really need to be thinking about go forward intentional data sets. And then the last part of the framework would be quality management systems, which we didn't talk about too much in the session, to be honest, but there's supply chain quality management around the systems and the cells, and there are key sort of accreditations you can lean into. OECD has just got a good in vitro practices accreditation that I think could form part of that overall framework. So I think that's really it. I mean, if we can establish a framework for early stage use, it will eventually benefit us in the regulatory space. And I think that's the main take home. I don't know if you have anything else to add, Madhu. Okay. That's it.